Hello everyone. Our project is sentiment analysis and the text generation of Asian Chinese based on AI model. Let me introduce our work brief. Our work has five parts: dataset and pre-processing, training model, contrast effect, final model and evaluation, result and extension layer. If we want computer to determine the emotion of a story and generate specific text, the first thing we need to do is to make the computer understand human language. But how? Encoding each word is a good way to do this, just as there is a color code for each color to make a computer understand colors. It's same as understanding language. As the first step, how should we encode Chinese? Which word to encode? English and Chinese are completely different in terms of word formation. For English, each word in English corresponds to one meaning or multiple meanings. With Chinese, on the other hand, Chinese is a language of separate characters, sometimes one character for one meaning, sometimes two characters for one meaning, or maybe four characters for one meaning. This is why the tokenization is so important. We have used Jiayan as a toolkit for this purpose. And Jiayan is a very professional and efficient at word tokenization in the language with few incorrect tokenized words. Next, we need to consider how to encode those words. We found two algorithms, one hot encoding and the other for word to act. We chose word to act because it has few emotions and can represent connections between words. In order to train word to act, we need a large data set with a very large number of forms that would allow the algorithm to get a link to each word. So we found the four collection of Asian Chinese forms on GitHub, which have 330k forms in total. Those Asian forms are saved in JSON files and are in the form of traditional Chinese characters. We simplify them. In the end, we use the Ganson package and trained of the training time and the word mapping effect. We train a 200-dimensional word vector. Those word vectors, you can see how they relate to each other. After that computer to understand the language, we must build a model to explore the connection between the form input and the type of emotion. We use three models: RNN, LSTM, BILSTM. I will briefly introduce the principles of those models where a set of abstract images. You can see that on the left is a simple single-layer structure, which is used by the RNN and LSTM. On the right is a two-layer structure, which is used by BRLSTM. The model will multiply the input first with the weight matrix and merge it with a previous output, a new numerical matrix. This numerical matrix will be converted in the activation function sigmod to an output of 0 or 1. In our model, 1 would represent positive and 0 would be negative. Simple binary classification, and the training process of our model is to keep changing the weight matrix in the cell to make the output match the expectation. You can see the loss in the RNN and LSTM polars fluctuate constantly, which show that During the training process, simple single-layer model like RNN and LSTM do not capture the relationship between words and Asian forms well enough to determine the exact sentiment type. So we adopt BRSTM as our sentiment analysis model. Our final model is two-layer architecture, one word-to-vector and on BRLSTM, on which we adopt a term folder or course validation evaluation method. Term folder method divides the dataset into term parts. Each part is used as a test set in one training section, and the rest is used as a training set to calculate their accuracy, loss processing, recall, and other metrics. You can see that our model achieved 90% accuracy in 1359 training sections and obtained an average accuracy of 8%. In addition to sentiment and model, we also wanted to create a poetry generator. Next, it's up to me to introduce the generator part. We use a different model from the previous layer, GPT-2, because BRSTM is a very old model, and the GPT-2 is based on the transformer. The fine tuning of GPT-2 is easy to do, and in embedding, we are using words as units, and the Chinese forms have a strict limit on the number of characters per line, so it needs to re-embed it. I will introduce the generator section. At the layer, our goals is to generate a poem. We use the attention architecture in transformer model to generate the poems. What we want the generator to do is to start the poem with our input and have it generate the number of characters and the lines we specify. We take this line as our input. Our model must guess what the most likely next character is by using those 7 characters above. If the guess turns out to be illogical, we make it guess again. In this example, when 4 characters is given as input, the model will use the 4 input characters to guess what the next character will be. At first, the model makes a random guess and guesses the character sky, which is completely incorrect. We tell the model the result and correct output. After training, our model predicts that the next character will be end. The character end will be combined with the input and become the new input. The model will use those 5 characters to predict the next character. This process is continually performed and eventually all the outputs are obtained, resulting in a complete form. The training process have given good results with a gradual increase and in accuracy and a gradual decrease in loss. Finally, our generator enables the generation of hidden forms and continuation verses. In the end, we prepared a generated form and translated it into English. Life passes relatively, such that grand days are lost in hurry fray. Legs find no home in this transient diving. In my heart, they cannot stay. Move spanning tales of fantasy and illusion. Yet we yearn for the dawning of real spring days. Thank you very much for listening.